Yes. Okay. Love it. Okay. Cool. Well, let's jam. So you guys have a calculator in front of you. I'm gonna grab one as well here. Desktop. We.
Doesn't matter what mode or calculators are in. Or you must have that stuff.
Yes, it will be important. Uh-huh. And we'll talk about it as well here. Depends on the directions, and I'm going to change directions on you as we go. Whoa, where'd it go? Come on. It's right here. Okay, I'm going to do it this way then. Has to be here somewhere. Voila. Yes. Okay. So I have a TI-83 set up. All the TIs are going to be pretty similar. Are we good? And let's jam with it. If you need some help, please ask. We good? Because that's the whole point of doing this right now. Okay, I'm going to put it off to the side, and then we can do it like that. Okay, let's jam. And just maybe a show of calculators. What calculators do you have? Real quick here. 84. 84 plus 84 plus C, 84, 84, 83, 83, 83. Okay.
He doesn't have
Perfecto. So if you don't have a calculator, just kind of look on with the person next to you. You guys can. We're good. And then I also, because some people don't have calculators, that's why I want to record this as well. So you go home and try it yourself at home. But people that are here with calculators, let's go with it here. So we're going to graph this guy. We're going to graph 1 plus cosine of x. And I want to graph it from 0 to 4 pi. So those directions, where it says from 0 to 4 pi, you know that we are in radian measurement. Is that right? So first things first, you got to do on your calculator is go to this little mode button right here. Mode, and you have to make sure that you are in radian mode. Are we good? And ask me if there's any other questions you guys have in the mode feature. Is there any other things that you guys have that's pulled up that's a little bit different than mine?
You make it another language than English?
Yes.
I guess so. Okay, with that said, let's go quit. You go back to the home screen. We good? And we're going to go this guy called y equals. Y equals. And doesn't matter how you write it, cosine of x, 1 plus 1 or 1 plus cosine of x. It don't matter. But let's go with it here. 1 plus. And Lucas, if you can share your calculator, so you guys can. All right, once you click on the calculator button, there's this cosine right over here. And tell me as we go, because you guys are learning this process. Does your calculator open up a parenthesis? Oh, yes. So y equals is right over here.
Here.
Oh. Okay.
X. You say the N. Just use switch that and.
And please, yeah, help each other out as well. We good? As you guys do it. And I sort of expect some talking between you guys. Are we good with that? Okay, let's go. First things first is, we know this here. What's the minimum? What's the maximum we're going to get over here, guys?
Zero.
2, yes, perfect. 2 will be the max. The minimum would be 0. Everybody agreed with that?
Yeah.
Okay, so now we're going to go to this little guy right here. This guy called window. Window. Yep, feel like Baymax. Fine. Window. Whoa, I don't want that one. Let's see. If we know we're going to have a maximum of 2, is that right? Minimum of 0. We want to stretch it out just a little bit further. So let's go like -2, right? To maybe like 5-ish. So that would be a little bit of a window there. Okay, the other part is this. That's the top and bottom. But the sideways. We have to go from 0 to 4 pi. It already tells us to do that here. So let's go over here. It says x minimum. X minimum will be 0. Click on 0. Are we? Then it says x maximum. There's our x max is 4 pi. So if you click on 4, and anybody find the pi button for me?
Right above it's the H arrow. There.
The arrow key, the caret key, the exponential key, it's like right here. So you got to put second and pi. And when you click on it, does it stay 4 pi or does it change it to a decimal approximation?
Or pi.
Perfect. Some people stay, some people it changes. It doesn't matter. This X scale. This X scale is those little tick marks that are on the bottom of the graph. That's what the X scale is. So how often do you want a tick mark on the bottom of your graph? Let's go every pi divided by 2. Look at there. Every pi divided by 2, we're going to have a little tick mark. So when you need to count it out, like, oh, that's pi over 2, that's 2 pi over 2. Okay, and then my y minimum is going to be -2 because I know I have a 0. My y max is not going to be 300. It's going to be like 5. And then what's my y scale? Most likely just by 1s. Now the rest of it don't really need the x riz. I didn't know you counted as a riz.
Oh.
Okay, we're good there. Yeah, it's the proportion between x and y, basically. But we can leave it as 1. Okay, are we ready for graphing?
Yeah. The delta.
I'm gonna go back.
Wow. Let's see. And let's see yours. Oh, how fast do you want it to change? And that's you can just 0.13 is fine now. Okay, any other questions on these settings?
Right here.
Everyone say doing good? Okay. All right, let's go. Let's graph this guy. On your mark. Get set. Click the little graph button right here. Zoom. That is so cool.
Why is it all messed up?
Bill says, that's so beautiful. Why is it all messed up?
I would be dead.
Oh,
It's beautiful at first sight, so it's not a setting.
I almost feel like it looks like a little snake, doesn't it? Like boom, but like just needs a little.
Wait, scroll sideways.
Yeah, like pull a bunch up. Gavin. Oh, perfect. Yeah, that's what we want to get to here. We're gonna graph a lot of these here for these students. We just want to make sure it's all set.
Where's a shape? Real hit that.
All right, ready to go to the graph. Let's go. I'm going to share some crazy stuff in a little bit here, but let's go. So we do need to know max. We do need to know min. That's kind of like priority, right? And we know how to do that now. All right, all yours by yourself. If you can, go. Ooh, we're going to add a little X next to it now. What happens?
We added to the same graph.
Oh, yeah, a new graph. All right, and here it is. I'm going to go from. Oh, there it is. I got to give you the directions here. So I'm going to say I want this from. Come on, where did it go? I need to go from x equals 0. Now I'm going to change things up for you all the time. Always. Shapes. All right, from -2 pi to +2 pi. Oof. All right, so -2 pi to 2 pi.
Is that for the X or Y?
Ooh, for the X.
Okay.
Now you need to figure out what the Y is going to give us.
You did.
Ooh, so question is going to be interesting now because you have this X in front. You're adding X instead of, remember, we're always adding constants, right? Now we're actually adding a value. Whoa, what is going to be the minimum of this graph? What's going to be the maximum of this graph? Vertically, yeah. We know what we're doing horizontally, right? -2 pi to 2 pi, that's easy. We just need to figure out this window now, the top and bottom window.
No.
I don't know. What is 2 pi approximately?
Sounds
6.2.
Okay, it's 3.14, right? If we double that, it'll be 6.28. And cosine, the farthest cosine can go is +1, lowest it go is -1. Is that right? So just in case cosine is -1 at that point, -6.28 minus one more. -7.728. Is that right? So let's go with it. Yep.
I only have friends in the home.
So minimum, here you go. So we'll unconfuse here. At -2 pi. Tell me if you guys agree. This is approximately -6.28. Is that right? For our vertical stuff.
Okay.
Yeah. Because our horizontal stuff is taken care of. We're going to go from -2 pi to 2 pi. Is that right? Okay, so minimum here. Minimum is at -2 pi. The x value is -6.28. Are we good? And if cosine, just in case cosine is a -1 at that point, how low are we going? -7.28. Are we good? Then we go back over here. Maximum at +2 pi. That is approximately a +6.28. And what's the highest cosine can give us? Plus one more would makes a 7.28. So now the question is this: do we really need to go exactly to a -7.28? No. Let's make it a little bit lower than the bottom, a little bit higher than the bottom. So talk to me here. Do we need to? We're not going to go -7.28 because that's the very bottom. We'll go a little bit lower than that. So -8 is fine. -9 is fine. -10 would be fine as well. We're good? So Addison, go ahead. What's your question? For the y value, yeah. So these are for y values. Since I had that question a few times already here, these are y values. Your x values have already been set for you right here. There's your x values. There's no change to the x values. We're good?
Okay. For the max y value, which is what?
So I'm going to go -10 to 10. If you did -8, that's fine. If you did -9, that's fine. We're good? I'm going to go -10. So now I at least figured that out. Now are we good?
Why?
Say again.
Yeah, well, and why is
Oh, scales. Yep. Let's go with it here. So going back to this, going back to y equals and clearing this out. Is that right? Let's put on our equation, which is x plus cosine of x. Tell me if everybody's there. Tell me if you're not there yet. You guys already put it in already, huh? Mr. Rajiv, we're faster than you. I understand. Okay. Window. Here it is. We're going to go from -2 pi. Everybody good there? -2 pi? To a +2 pi. All good there. Our tick marks. I generally like to put them at pi divided by 2. Because then I can start counting. That's pi divided by 2.
Wait, let's keep the slope the same.
We can't, unless it's like really short, you're going to only go from 0 to pi over 4, then you want to make it plus. Okay, so y minimum, how about a -10? Y maximum, a +10. And there's your y scales again. Generally, you want to keep it as 1 unless you know it's going to be something really, really off. But generally, you want to see about 20 scales on your screen vertically. Okay, are we good? Pressing the grab button. Let's see what we got. That is so weird. So interesting. Go ahead, Sam.
Their case. Oh my goodness.
Interesting. It models this little piece there.
Oh, it's terrorists, but TERRS. That's like a mountain. You know, when you're
Kind of cool. So hold on. With this trig functions here, can we model like mountain ranges, the view of mountain ranges? Maybe?
sure.
I don't know. Model something that curves wrought iron fences that actually have curves to them. Is that right? Can we model that way as well? Right? Okay. Let's see. So Sam had a question here. How come it's doing this? Which is kind of interesting. Notice Notice, remember cosine goes from like negative, positive one to negative one, right? It kind of goes like this, right? It fluctuates, right? So Sam, just a real quick interesting thing for you. If I were to graph just x by itself, notice what's happening. So notice if x is by itself, cosine goes to negative one, positive
So
one.
it's going to affect on the X line.
Yes, yeah.
On the X, Y axis.
As opposed to the x, y axis. Yes, absolutely. Kind of cool stuff. Uh-huh. Oh, okay. What two trig functions at the same time? I want to go from negative 2 pi to 6 pi. All yours.
What is this? How is it like
Alright.
unless
Maybe would work too. I'm trying to estimate with you guys there. So like, you want to go like maximum. Oh, go name. So we'll try to do this again on this. So class, just to practice the max and minimum here, real quick here. Ready? Minimum. Notice this time. And again, this is only for the y values, right? Y values. We're trying to figure out the y values here. If I can spell.
oh
Can't spell yet. Value was minimum. Okay, what's the minimum sign can go?
1 half negative 1 half?
Yeah.
But no.
I'm gonna go. Minimum sign can go is negative 1. The minimum sign can ever go is negative 1.
Oh, yeah.
What's the minimum cosine can go? And I don't even care about the 2 there.
1/2. No, negative 1/2.
Negative 1/2. So negative 1 minus a half.
Negative 1.5.
Negative 1.5. So the lowest this graph will ever go is a negative 1.5. Are we good? Okay. So you guys good just on the minimum, ready? So because sine is a trig function, we think about this guy being the lowest it can go is negative 1. Cosine is a trig function, the lowest this can go is still negative 1, is that right? But there's a multiplier in front of 1/2, so it's 1. We're good. So according to the graph, the lowest point of the graph is negative 1.5. Good. Let's jump to the highest point here. The max. The max here is going to be 1 plus. Okay, are we good there? So the maximum of this thing can go is positive 1/2, right? So our vertical scale, right, is not going to be from negative 10 to 10 anymore, right? It's going to be a lot more shrunk. Now, do you have to do it by min and max? No, you could just kind of draw the graph first and then kind of coordinate it. But let's go. Okay, all yours, go. And then as soon as you have it, show it. And, cool. As soon as you have it, show it. And if you don't have it, ask your neighbor. But just go like this, boom, shows me the screen. I want to see your screen.
This guy got cavity. And then. I think I have about this is great.
Something is slightly off there.
This is what we should get. Isn't it 6? No. You don't change it.
Negative 2. Yeah, negative 3. Okay. Yes, awesome. Got that one. Perfect. All right, show me your screen when you got it. Aramis and Gavin, show me your screen when you got it.
He goes it down.
Addison, you good? No, okay. That's why it doesn't show up. It disappeared. Okay.
Is this?
It's doing good there. Let's go window now.
Oh.
Negative.
Oh, yeah.
Then.
I feel like that's.
I just
check your
yes.
Asking. I don't know if that's your favorite work. I did it. I used to. Oh, yeah.
I did it.
I know it's.
I think they're available.
Yay! This is the third one.
Interesting, but.
I think my favorite. Wait, in here, a typo or
What'd you get? I mean,
These are just one.
I'll some more questions on that one.
That's a simple.
Oh,
Yeah, that's what I'm saying. I'd rather see it. Son of you. Cigarette.
It's that kind of game stuff. Working on. I did. Yeah.
So you want to know?
I don't know. If I will.
All right, class, we go. Gavin, Aramis, you guys got yours? Yes.
I don't know, my numbers are weird. Just like.
Awesome.
Yes.
I didn't just know that part. I was like the fact that it is sing really fast. Yeah. The thing. I don't see.
What the thing you do is say.
It wasn't.
They look like vines. It's just that the thing you do is say. They look like
He was. He was like.
I mean, I'm brutal.
Dude. It's so good.
More than you were today.
Everything's gonna be -2.
You know, American.
I know. The Mary's. They
invited.
Oh.
Like
Pascal was like background, like a web. So then we were a mouse.
that version was terrible.
It's like itching. I don't know why I kept trying to write that. It's just not psychic to me.
I do, by the way.
And then later on, like, you're probably not.
Wait, there's
The way you drive it looks like she's.
there's other stuff.
Sister, you do. And then she.
No, it's that's only.
That's
feeling
I was sad that.
What did you guys talking about?
That's fine. This guy changed his voice
Style.
It's actually really cool. But like, it's something cash stuff. And I had like smell.
What the lady just saying?
So it's still looking around because.
You don't see that? I are waking up.
Okay, is that good?
Oh, it's funny. Oh,
Straight out both of them. Hey, well, this is my night. Yeah.
All right. You guys good? And I think everything's here. I gotta do this. And I think everybody got this one right here. Sine of x plus, I'll just do 0.5 cosine of x. Cosine of 2x, that's right. Everybody good there? Window is from -2 pi, yep, to 6 pi. I just have to catch up with you guys now. Boom, boom. I'm going to go -2 to 2. If you went -3 to 3, that's fine too. That's cool, but we should have a graph that looks something like this. Is that right? Like little molars on our teeth. Is that right?
It's just your.
That is so cool.
I had forgotten to so we're
That is so funny. Okay, so that is so cool. So we can model stuff that actually has like teeth modeling. That's kind of cool too. Okay, next one.
I'll go for you. Oh, you're the why letters empty.
Another one. Go for it. And just sign value only.
That was with factors.
Is that?
Oh, okay. That's rain window would be. It's in.
Window.
Wait, what's the range of this?
Oh yeah, that's right. I got to give you range here. I got to go 0 to 4 pi. Thank you. I'm gonna go back over here.
I'm showing that very well.
There.
Oh, yeah, B 1 minus, no, 1,
Yeah.
with negative 1. For the men,
So sine of 2x. This guy lowest will go as -1. The lowest, this guy will go -1, except you have a minus 2 in front of 2.
yeah.
So
Would that be
technically
2?
it would be -2 is the lowest. This whole thing.
Okay, that's just negative.
-1 minus 2.
Negative, that's negative. So, okay, that's 0, 3, like this. Negative 3 first. 0, well, 0 here.
It's always.
Actually, negative 0.
Would that be
I just adjusted. I don't know why max. You could calculate that's negative.
My last name. I don't.
How it works.
I think this is right.
Well, the minimum would be negative 2.
Oh, yeah. So we.
It might be.
I don't know, but.
Negative 3. That's
The line is like.
1 plus. How do you say that?
Bless you.
Just adjusting. Yes, it's y.
All right. And hold it up when you got it. So what was your minimum? Let's do it together. Okay. Let's do it together. First things first is we got to figure out. Oh. No. Okay. So let's see how we do this here. So y values.
I think so.
Let's see the lowest minimum. The lowest this guy can be is -1. The lowest this whole thing could be right here is -2. So -3 would be the lowest. Are we good? Right, because it's not so much the lowest sine of x could be, just the whole multiplier as well. The maximum.
Yeah, we got.
Maximum would be a +1, this guy. This whole thing would be a +2. And I got myself a 3. We're good there. Boom. Okay. 5 and 2 here. All right. So look good.
It would just be negative 3. This.
Yes. I'll probably go -3, -4 to 4, or -5 to 5. Right, because you want to have a little bit of extra space. Root. -2 sine of 3x. I don't know if it's the right. Okay, we're good there. Will, are we jamming there? We're good? 0, 4, pi,
Such as that.
-5 to 5. Okay, here's what I got for my settings. And tell me when you got it.
Okay, so. I'll see the picture.
So I would want.
It looks like. I'm funny.
I don't have to do it.
Oh, how funny.
So
Okay, arrhythmic heartbeat.
Bites.
Then we walk around just quickly.
Wait, you guys get.
Okay,
I'm trying to get.
Ours is like that, look, shrimp. You guys have to spawn.
Yeah, I mean, I think. Do you guys like a? Do you guys do like a longer like body thing?
Yeah.
Well.
That's scary. Oh my God.
It's alright. Like, what was your y minimum? Or is it the all?
Wow.
Oh, so they like do it like Southern New York. Just you have like those. I'll see. Yeah. You ready for the players? Yeah, because if I change it to -3 and then watch it, I just need to change it. Yeah. Yeah, man, you can look at some. So that's like one of the rapid.
That's what we calculate. So
We'll see.
I did it from -5 to 5.
Believe it when it says
Now we
that.
have to calculate based on the trig function.
Smallest.
What causes it to change? The rest of the I understand.
How do you relate?
Yeah, okay.
So. Right.
Then negative five. That'd be more space out. Yeah, because.
Yeah.
We always have 40. Okay.
I should start off. Seconds and change. Drop.
Yeah.
Oh, yeah.
Where did we submit? Didn't we technically already do that in the, we start writing
All
something?
right, class, let's go. Did you get a graph that looks like this or kind of, sort of?
Always learning.
That is so interesting. So it goes, is there a pattern? Does it repeat itself eventually or no? Where's the repeat?
Like right there.
Like towards the end, like the, after the third hill.
Okay, yeah. So like here and here, here's your, right there, right? There's your repeat.
Yeah.
But this whole thing, so it's going 1, 2, 3, and then back up to here in order to get that.
Oh, no, so much bigger.
Interesting.
It's a period.
All right.
It's like if you were to take a picture and like of the sister, her ancestors at the age of below.
Uh-huh.
You see them like go up and down, like
Interesting, yes, uh-huh.
Or mountains.
That's cool. Okay,
I see.
are we good? Okay, we got that. Okay, how about this one? A little bit unusual one, all yours here. All right, so because I have a pi next to the x, what I'm gonna do, my period is gonna be a little different, and I want to go from 0 to 8 this time. All right, it was something that we looked at before, got the little x over here again.
No.
Still climbing. Still climbing.
That would be.
Are they gonna give you the
Wait,
X men.
wait. Would the Y min and Y max just be like the maximum cosine of x we go, or
Thinking.
would that be the maximum cosine of x we go plus the x?
Yeah, so the highest x goes 8, right? And then you're thinking about, cosine was the highest right there, would go to 9, right? The 8 plus 1.
I did. Okay.
And they go,
So like,
Like this we will.
like 10, like negative 10 to negative 11 to like 10.
I'm a negative 10 is fine, yeah.
Okay.
I'm gonna try a little something here, let's see.
Wait, so, what's next?
That help.
Wow.
7 for like
So the
that.
X
It's okay.
I just want to see how much of a,
8 and then.
It definitely.
Whoa.
I just thought it was definitely nice to take our time. Like, one more normal, it's like.
uh-huh, gotcha, okay. Yeah, just, there's not enough of those, so we'll see.
So it is.
X,
Yeah,
the
I
height.
have to be like, okay, when do we put them up, when do we not put them up? Sort of thing.
And the height,
So I have to make it removable.
uh,
All right, class, let's go. We got, yep. Let's go with, y values minimum. Ooh, okay. Anybody with a minimum yet?
-9? Wait, no.
0.
0, no.
Wait, the lowest.
-1 would be the possible, right? Hypothetical minimum. So at 0, x will be 0, is that right? And at 0, you could calculate cosine, because cosine actually will be 1 at 0, is that right? But if we just want to say, okay, what's the lowest cosine can never go is -1. So, oh, we good there? The minimum would be -1. Are we good there? Now, if you wanted to, you could actually compute what cosine. Cosine of 0 is 1, so it actually would be positive. Does that make sense? We're just trying to make a window for us. Maximum. Maximum is 8. What's the maximum cosine can go?
1.
1. So we got ourselves maximum is 9. We good?
Okay.
So now what do we want to do? I want to go from 0 to 10. We good?
Okay.
0 to 10 would probably be good. So this one go a little bit lower. This one go a little higher. There it is. So let's go with the ear. So shunk.
That's fine.
That's the y minimum and y maximum plus cosine of pi x.
Okay, we got it. Weird.
Three words.
We're good. Okay. Are we good there with that? Okay. And then we're going to go to window. Window is going to go from 0 to 8 this time. And now, instead of there's no more pi over 2's, right? We just want to make a scale from 0 to 8. Let's go by 1's this time. So for every tick mark we see along the y-axis, it's going to be a 1 for us. Okay, minimum is 0. And the maximum is 10. Doom, 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 doom. Okay. And tell me what you guys got. Okay. All right, and the graph looks like. So it does hit a 0, right? Oh, that's interesting. Cool.
Oh, so.
Yeah.
Okay, are we good there, guys? So there is our graph of an increasing slope value. Now, notice whenever we put pi in here, right? Notice what happens is it gives us exact values of stuff, right? Now we're actually going from 0 to 8. So if we're looking at centimeters, if we're building a staircase up, right? Now we know exact dimensions of how high we want certain things at certain times. Right? And so at maybe like what, 2 feet from the beginning, there's 3 feet, there's 4 feet from the beginning, there's 5 feet from the beginning, and now you know your whatever it is, with this wrought iron or whatever it is. Okay. So now let's do this here. Let's go with
Mason. So with the 4.6 homework asks us to use our calculators to grab it?
yes, 4.6. In the past, I used to do it by hand,
Okay.
and it took way too long. So this would be a good opportunity for us to learn how to use our calculator. So class, on your homework, all you got to do is to graph it on your calculator, make the same dimensions on your sheet of paper, and then just kind of do a rough estimate graph on the same one that you guys did on the calculator.
Is 4.6 on Wednesday? I don't know.
Do Friday. Uh-huh.
So 4.6?
All 4.6. Uh-huh.
Just had a graph.
Just graphing by calculator.
Okay,
That's
cool.
all it is.
I like this.
Oh, cool. Okay.
Oh, this ain't 4.5.
All right. Say again.
On Desmond.
Ooh, yeah, you can graph it on Desmos.
Awesome. What would the 4.6 call?
4.6 homework. You're gonna graph this. Uh-huh. So on your sheet of paper, what I want to see is the dimensions, like in this case. It's going to be a recreation of this graph right here. So then you just show me the direction. This is 0. This is 10. I went out to 8. And I have a graph that kind of looks like this. And that's what I do. So a recreation of the graph. But give me your labels of especially X and Y, labels of where you're at. Anya?
So kind of at a maximum, making from 0 to 10.
Oh yeah, just so we can see the window, easy. Because if you go directly to the graph itself, then you just don't see it as nice. I mean, like whenever we want to frame a window, right? We usually want to see extra space. That's essentially what it is. Okay, so then if you guys want to do this one with me, good.
Or I'm drafting like this on Desmond, so we have like a version of the window button.
Yeah, uh-huh. So let's go that. Let's do Desmos real quick here, since some people are going to do it on there. Desmos. So cool. Calculator. Zoom. Let's do 2 just real quick here. So, let's do the first one I did. 1 plus cosine of x. Good there. So no dimensional change. The only thing is I wanted it from 0 to 4 pi. Is that right? So over here with the little wrench, there's your graphing settings. So x-axis, I want to go from 0 to 4. And then the designation on computers usually for pi is pi. When you click on pi, it turns into that little guy right there. And then the step process. I think I can just do pi divided by 2. Let's see what happens. Whoa, this is weird. Pi divided by 2. There it is. Okay, and then we found out this is for number 1, right? Anybody real quick? Example number 1. What was the min and max for example number 1?
It's not your right.
It was -1 and 9.
Okay.
Wait.
I think it would, well, it went from 0 to 2 to 2.
That was for that.
I was going to go, I think -2 to 4, I think, was it? Okay, so are we good there at least? Boom. Okay, then you got to move it around. Okay, well, looks like you're gonna have to go like this though, right? Oh, well, it took off. Here's 4 pi right here. So you got to decrease your window to get your beginning end on decimals. Okay, anybody else want to see decimals on this one? Okay, boom, boom, boom. Next is if you want to do this one with me, this would be kind of cool on the calculator again, I think.
Yeah.
So I'm going to go a little bit faster, but if you want to keep up, that's fine. If you just want to sit, relax, and kind of look at it, that's cool too. Here is boom. All right. These guys are called square waves of sine curve. It's when you start adding more and more together into it. And let's go with it here. You start, we want to see the progression of what happens. We good? So I'm going to click on this. Now we're going to add 2 graphs at the same time, or 3 graphs. So I'm going to go sine. Whoa, okay, never mind. That's not going to happen. Sine of x. Sine of pi x. Okay. All right, these guys are called partial sums. So we just want to see how things affect the graph. So this guy, we're going to graph from 0 to 2. So let's go over here. That's our graph. Window is going to be from 0 to 2. X scale, and we'll just leave it as 1. But we know sine value, lowest is -1 to 1. So let's go negative. Let's see. Gonna see here. Let's go -1 to 1. So -2 to 2. By 1s. Okay, sine graph. Are we good there? And graph it if you like. Is that true? That is just a regular old sine curve. Is that right? Cool. Okay, here's what we're gonna do. We're gonna add to it. We're gonna add to this guy now. Plus. Whoa. Oh, my calculator doesn't work that way. Plus. Sine of 3 pi x divided by 3. And the 3 pi x is inside the parenthesis, and the bottom 3 is just dividing. All right, well, and then let's see how it changes. We're good? Previous one was a sine curve. This one is a
Oh my gosh, it's the truth.
is the other way here. So now the question is, if I add a 5 pi divided by pi, what's going to happen next? It's what? Make a square. Okay, so let's go. I'm going to go back again. If you want to just chill and look at it, if you want to see it here, this is sine of 5 pi x divided by 5. and graphing this guy.
I was too close.
We're good. So if I put a 7 in there, there's just gonna be more, yeah, more bumps at the top and the bottom. Is that right?
Where's them?
Uh-huh. If I were to make now, notice I made sine of pi x. Now I got 3 pi divided by 3. Then I got 5 pi.
Fine. Five x divided by five.
Mm-hmm. All right, as I just put more and more waves into here, right? It's gonna, in a sense, I'll do one more here. So sine of 7 pi. We're good there. So then we just add more and more curves at the top. We good? And it still crosses at 0, 0. It still goes down, but we have that. All right, what is that? That is something called a square wave function. And then it models straight across. It's still gonna have those little wiggles, but less and less wiggles, right? So eventually you can actually make it go up to the top, almost a square, almost bottom, almost a square on the bottom, but it has just a little bit of variation on it. You can make it. So, anyways, that's cool. Can you model sound waves with this? Absolutely, right? Can you model a whole bunch of like the 5G network patterns that we have on our phones? Absolutely, because those are just radio waves and sound waves, right? That's all. And I think we're done for the day. Oh, 4.6. Yeah, I'll send you guys a study guide sometime today, tomorrow-ish. And we'll come back together. We'll do 4.7 and then we'll have a little test.
Wow. Yeah, good luck in the town.
All right, you guys talk to me here.